Everyone can hear me? All good? I'm quite loud anyway, so it should be fine. First of all, thanks for such a great turnout to the security dev room. Like, it's absolutely amazing. It's been completely packed with people, so awesome. Good job. So my name is Chris. I work at Facebook London as a security engineer. I'm the lead on a project called Sesto. It's essentially, I was told by an Italian, that means basket in Italian. So for all you Italians out there, I'm sure it's a great name. So this is basically one system which handles SSL automation and monitoring at Facebook. I'm going to go over some of the modern best practices for running TLS, both at scale and in general. Mostly high level at the beginning, mostly general procedural stuff, but I'll go into some low level tips at the end. Oh, and I would usually say, feel free to interrupt me. This talk is like running right to the edge, so I'll answer all the questions at the end. So there's 3 sections. They might seem a little bit different, but they all generally address the problems you'll have running SSL. Let's go. So the 7th of April 2014 was kind of a special day for the World Wide Web. For some definition of the word special, and perhaps never before had so many system administrators said the word shit at the same time. So what made Heartbleed special? Well, it was one of the first OpenSSL vulnerabilities that could practically result in the disclosure of your private data. Namely, user passwords, private keys. All of this was originally thought to be theoretical, and then it was shown to be actually very practical. And if some random guy on the internet gets your private key, then you're completely messed up, because they can pretend to be you to anyone. And if you don't support forward secrecy, they not only can pretend to be you to anyone, they can also go read all your previous communications, which is always fun. So Heartbleed affected pretty much everybody on the known internet. Everyone wants to get them rekeyed, revoked, put back out to their servers, and the CAs were simply not ready to cope with this. I'm sure any system administrator in the room who was working at that time can attest. Absolutely nothing was working that day. Like, literally, you couldn't get anything reissued because they were totally reissued. And inside companies, people were having like a mental and physical panic and running around like everything's on fire. So it was pretty chaotic all over the place. Basically, nobody was ready for this thing to happen. So the work done inside companies using SSL is mostly what I'm going to cover today. I'm going to go over some of the challenges we had after the announcement, some of the steps we took to mitigate Heartbleed and attacks like it, and some of the things we could have done better and we've learned from. So Facebook has many thousands of services, and I'm sorry to the people who are on the small video who can't read what that says at the bottom right. Working out which services are actually vulnerable is quite challenging. So this is not just like HTTPS. It's not like the only thing I serve in my day is Facebook.com. This is like MQTT over TLS for messaging. This is secure thrift for RPC between our services. This is SMTPS for like our corporate mail gateways and like forwarding out to the world. This kind of stuff is not easily enumerable within our infrastructure. So acquisitions have all their own infrastructure. Maybe we migrate them to our infrastructure eventually, but often they keep some of their infrastructure. There are things we have to store outside of our infrastructure for compliance reasons. There are microsites which are hosted on things like WordPress or other third-party hosts because they don't need any access to our infrastructure. They're just like marketing sites. There are so many different types of deployment that it's absolutely impossible to enumerate what is every single thing that we own that serves SSL. It's just impossible. There are some places to look for service kind of things. For example, we can look in our service deployments for stuff which links to, for example, OpenSSL. We can look in Chef to see what services are actually deployed to machines, so you can see where you need to redeploy them. And we also did stuff like scanning the whole of our IP space to try and work out what's going on. And I told you, we were in like a panic, right? It's like, we did like passive checking of all our data center traffic to try and see what's encrypted, how the hell can I find out which certs needs doing it. This is very time consuming and not accurate. It's basically the thing you do as the last resort is in like an absolute panic. So you need to make sure you have a better deployment strategy than that. I'll go more into the better way later, but let's just go over some of the challenges for now. So even when you've worked out what services need to be fixed, you probably don't know who can fix them at this point. You might have some huge service, like Facebook has tons of huge services for the messaging stuff, and for obviously like your newsfeed and stuff like that. But identifying like smaller services which might be critical in their own way is very, very difficult. They might not even have any documentation, they might not even have any on-call rotation, they might have absolutely no information. The only thing you know is there is a service running on some machine, and I have no idea who the hell owns it. That's one of the best and worst things about working in a huge company is when you discover something is running in it, nobody knows what it is, or has asked it to run. It's kind of Skynet-like. So we also faced logistical challenges doing this kind of thing quickly. The start time is not far enough in the past. Like literally, I'll say the statistic again, I'm sure, because it's mind-blowing. We did some preliminary statistics on Android, on our FE for Android app. 5% of users, if you don't set your certificate to start that far in the past, like 1 year in the past, will simply fail to connect to your service. That was our experience on Android. This data is slightly skewed because of retransmits and stuff like that if you fail. But yeah, it's one problem. And the second one is we didn't have the right routes for pinning automatically. When we went and asked our CA to go and reissue the certificate, they reissued it with a pin which we didn't have available, and yeah, then that was very, very bad. So it needed like manual intervention, which is awful. And even today, like automation for special certs is really, really not good around the web, and it needs to get better, and it is getting better with time. So some solutions. So when Heartbleed hit, Facebook was kind of in the wild west of certificate issuance. People bought, and I'm sure it's a very familiar story to lots of you, people bought and monitored their own certs, and like, we didn't have a clear view of the world. We didn't know who was buying from what CAs, what the story was on their service. It was really, really bad. So we started to move towards storing and issuing certs centrally to get a clearer picture of the world. That way you can enumerate them all super quickly. You don't have to go find all the endpoints that use them. You just have to store and issue them centrally and keep it up to date with the world. So this drives down all the technical debt across the company because now you don't have tons of people implementing their own monitoring. Like some people had coded their own monitoring in their service. So you would see like some code which checks the certificate which you're serving. But like, if you have to do that for every single service, it's a complete nightmare. And some teams had a more basic solution, which was to set like a calendar reminder on somebody's Exchange calendar. And then when they left the company, that calendar reminder proceeds to absolutely fuck all. This general procedure is complete crap, right? Like you have to have some way of enumerating them that doesn't, and like alerting on them that doesn't rely on every single team understanding how SSL works. Because the reality is people don't understand how that works. You have to have some level of expertise in some team, and they have to help out. So having them stored centrally does mean you can do things like enumerate certs which are vulnerable to certain types of cert exploits based on their cert settings. Look at stuff like if they have a key which is not forward secret, and generally like you can get them reissued and do things quickly. So nowadays certs are needed for every service. Storing the point of contact, preferably in on-call rotation, is very, very important because you probably don't know who issued them. You need to also get them pushed out of prod quick. If you store them centrally, you can have a situation where you can have your deployment routine automated on the server, ready to go every single time. And you can also do automated monitoring of your certificate data there. But you also have to make sure that monitoring is kept up to date. Like if you store an on-call, there's a person or a rotation, you have to make sure that on-call actually makes sense. It's not just some static string you store in your thing. It actually exists and it has more than 0 people in it. Because if you have 0 people in it and it comes down to crunch time, then it's not going to be fun for you. So automation is really, really critical to rolling your certs and or donuts quickly. So you can have way more confidence in doing this super fast if you are already reissuing often already. So like I said before, when we reissued, we didn't realize we hadn't issued the certificates far enough in the past. We didn't realize that we had the wrong routes. If you do this frequently, you will know exactly what should happen and you will have some automated process which can deal with that for you. You can also do things like checking for lacking machines when your pool runs over. I mean, it kind of sucks if you have to reload your services. There are some services which just have to reload when you get new SSL credentials, but ideally you should build your services in a way that you can reload the SSL certs and you don't have to restart like stuff and drain your entire pool, because that kind of sucks. And you also need to know which services are under attack. Rollout takes time. You need to prioritize what you're going to roll out to. Somebody's stolen your RSA key or whatever, your EC key. You need to reissue, revoke, deploy right now to avoid a man-in-the-middle attack. Like, it's just not feasible for you to wait on that kind of information, especially if there's a big site. Also, you need to be able to quickly log suspicious requests, bearing in mind that you don't know what suspicious looks like right now. If some attack like Heartbleed happens in the next 5 minutes, you don't know what it looks like right now. Nobody knew to look for SSL heartbeats at the time that Heartbleed had, just before Heartbleed had occurred. You need to be able to push that out without a full code push, especially if you're in a company like Facebook where code pushing takes some time. We do it super regularly, we're very confident in it, it still takes time to push out to hundreds of thousands of machines. So you need to build hooks into your infrastructure which can log the right things. You also need to monitor suspicious network requests for devices that can't do that themselves. As much as we hate these things in the security community, intrusion detection systems are pretty good for that. So to monitor everything. So in previous section we talked about centralizing alerting. So the goals are basically to reduce tech debt and reduce duplicated work. And doing it at as much of a low level as possible seems to achieve these goals. So where can we get that low level? So it seems logical to do it at the SSL vendor. Many of them provide notice of expiry. It seems a sensible place since the state of the world is there, but there are some lacking areas. Like they send you an email which says your certificate expires in 90 days, 60 days, 30 days, 7 days, your certificate is expired, you're fucked. It's like that level. It's not something which you can deal with very, very well. You need to build like your own ownership, deduplication, like prioritization frameworks around all these emails. It's not very sustainable unless they have some API which you can actually retrieve this information from, which I'll go back to later. You also probably want more types than just expiry alerting, which is the typical thing which a CA will give you. You also want stuff like invariant violations, like SHA-1 expiring after 2015, known insecure attributes, chain expiration, like your key doesn't have enough bits. Those kind of invariants are very important to monitor too. And also you'll likely just generally use more than one CA eventually. Like you will have a company acquisition, you'll need it for a backup pin for like HPKP or some of those kind of pinning, and so this might not actually match everything you think it does. Okay, so we can't do it at the SSL vendor, so it seems logical to do it at the SSL terminator. So as long as you're only going to use ever one kind of termination software, totally fine. But as we know in most companies, you don't end up using one kind of SSL terminator. You have like a million different services and they all do their own crazy SSL stuff. Like I said earlier, we have some stuff on WordPress and stuff like that, so it never even is seen by our SSL terminator. Yeah, so realistically, for the long term, I don't think that's a good way of going. Or at least not a good solid way of going. So if those aren't enough, then where should we do it? So there's no place where certificates naturally all exist together, usually. So you have to create one. And actually creating it is only half the problem. You need to keep it in sync with reality. So you need to request, issue, and deploy from there. You need to keep it naturally in sync with the whole place. If you don't do your operations from there, it's going to fall out of sync as soon as you start going. It's also easier to bake in like company-specific logic in your service that way. Like I told you, like on-call rotations, deployment strategies, those things you can bake it into that service. And also this is like a box inside your network, right? So you can do E2E testing of your certificates. So it's possible to check that the cert that you think is on some service is actually on some service. And that's important because there are lots of problems that can happen by you not communicating properly with everyone else what you think should be on their service. So each of these is good for different things. For example, only the SSL terminator can tell you what's going to users, and only the SSL vendor can tell you what the world actually looks like from their way. So you need to work out your own requirements and go from there. So we alert at the termination and the certificate store levels, and in a pinch I would definitely at least do the cert store, because then you have full ideas about what's going on in your world. So this seems deceptively easy, right? Why is he telling us about how to monitor certificates? It's just some file, I can like read it with OpenSSL. How does that work? Monitoring is super difficult for large organizations. Like these headlines are from the last year or two. And this one, the Instagram one, I personally was responsible for this kind of thing. Thank you very much. And I can tell you for sure that headline is not accurate. What do you mean? Tech news sites are always accurate, you say. But, well, I hate to tell you, but you have been misled. What actually happened in that case is I renewed the certificate, I got it pushed out, and then I discovered actually there's a bunch of endpoints that I didn't know about when it got pushed out. So, you have to have some automated deployment. You have to understand like everywhere you're deploying to. Instagram is a complicated product. It has tons of endpoints. You can't just believe which endpoints. You can't just imagine them in your head. You need to make sure you have end-to-end testing of every single asset which should have that cert. Right now, regrettably, the software which we're developing at Facebook is not open source. It sucks. For solutions to SSL management, I highly recommend Lima by Netflix. Very, very smart people developing that. It's very well engineered. If we hadn't already been writing this, I would totally use that. It conforms pretty well to the best practices I just laid out. Let's Encrypt, also very awesome, free, open, automated CA by the ISRG. We're a gold sponsor, gotta get that out of the way. The API is improving all the time. You can add to it, you can work with them on developing new open standards. And I said it's not worth developing stuff necessarily for CA integration, but their API is getting better all the time. So maybe it'll be true sometime. So, for the final thing, so I talked about the high-level fundamental things to get right. Now I want to talk more about the juicy low-level implementation detail. EC, very, very awesome elliptic curve sets. We already had some talk about it earlier. So we saw 5% fewer machine clock cycles and 30% fewer machine instructions when we switched from RSA to EC, which is amazing. That's like when you say I can save you 30% of like machine instructions to some Facebook engineer, they will like faint with amazement. Also, you get forward secrecy, very, very important. Security is just a function of time. Eventually, everything's going to be compromised, so you need to have forward secrecy so that people can be confident that your system is going to be secure for the future. Problems: EC chains not well trusted on old devices. ECDSA, ECDHE, those kind of things. Relatively new, the trust chains are not well distributed, so you can ask your CA to give you an EC cert, and then give you intermediate, which is an RSA intermediate going to an RSA route. You still get all the awesome benefits of ECDSA key operations, like 30% improvement in performance, but you also get the trust, the trust on all devices. Awesome. So CT logs. So CT is certificate transparency. I'm sure some people in this room have seen this kind of stuff going with the Symantec stuff recently. It basically logs new certificate issuances by CAs. And it's useful for many things. It's useful for looking at domain misissuance, in the case of Symantec, misissuing google.com. It's also useful for catching new phishing domains that might use HTTPS to appear legitimate. For example, if somebody wanted to spoof Facebook, they might also get the HTTPS certificate for some domain which is not Facebook, just to appear legitimate. So it's kind of useful to find SSL issuances which are relevant to your interest, for whatever that may mean in your case. There are some limitations. Only EV certs, extended validation certs, are required to log to CT. That kind of sucks. Like even we don't use EV that often. Many in the security community and I would like that to change. I personally would like every single member of the CAV forum to have to do that. But yeah, I mean, I'd like to see it, but we'll see how it goes. So bear in mind it's not comprehensive necessarily. We personally log all our issuances, EV or not, to CT log because we think that's the right thing to do. Also, don't leak your new shit in the process. If you have something called awesomenewproduct.com and you just got a certificate for it, yeah, that just became public information. So don't do that. Like, don't issue an SSL cert under your CT log in advance of some new product. That's probably a very bad plan. So don't buy coolnewproduct.com just yet. HPKP, so the thing which I can never say correctly at speed. So it's a great way to stop a rogue CA, of which there have been many. Did you know tar? And also you could argue like what Symantec did was the actions of something rogue. It's a great way to stop a rogue CA from issuing stuff for your domain. So after the first load, it tells your browser to only accept a certain set of public keys, and one of those public keys must be in the chain which you serve. It can be the leaf, the intermediate, the root, it can be any of those, and those all have different kind of properties. So many people recommend chaining to the intermediate, recommend pinning to the intermediate. Reason being, then you can like issue whenever your cert gets compromised, you can issue a new one from the same CA, great. But we can do better than that. Like I would recommend pinning your leaf cert, which is the cert which is actually for your domain, and then going and putting in a safe some copy of some backup keys which you have with some CA. Otherwise, you can just get compromised by your CA again. There's also an awesome feature of this, which is you can also just do report-only mode, which is like it will report chain validation errors to some URL of your choosing, which is awesome for like checking if some state is about to attack your users. We're coming pretty close to the end, so I'm going to skip the next slide because it's basically the same thing. You can go to this URL at the bottom and see all about it. It's basically HPKP, but not HPKP. So performance. So finally, performance has traditionally been a concern when adding TLS. There are some simple steps you can do to improve performance. So one is handshake optimization. You can use TLS false start. TLS false start has been kind of an iffy thing. Like browser support is kind of iffy right now. It was in Chrome, then it wasn't in Chrome, and all sorts of stuff. It basically paralyzes the final part of the TLS handshake, removes one trip, but the browser support is issue. One thing which is very, very awesome is TLS resumption and caching. I'm sure everyone in this room that runs a TLS deployment will run some kind of TLS resumption and caching. But you need to make sure you rotate your encryption keys, your ticket encryption keys. Really, like the number of websites we've seen which don't rotate their ticket encryption keys and like destroy any belief in forward secrecy is unbelievable. I will skip that. So for the final thing, using OCSP stapling, you can avoid having your users look up OCSP records from your CA, which can add like tons and tons of milliseconds to your handshake time. Essentially, you have the CA sign your OCSP record, and then you present it locally when you present the rest of the stuff to save time. Cloudflare, for example, reported 30% improvement in overall SSL setup time. 30% improvement in SSL setup time is amazing. Cool, so thanks for everyone who gave feedback on this talk. This talk would be absolutely nowhere near as good without their effort. And we now have maybe 5 minutes of questions, so I'll open the floor to questions, and thanks very much for listening.
What's your fantastic question?
Hello.
What was your stance on
What is my stance? My stance is awesome. Yeah, so the thing about HSTS is it's very, very awesome in the fact that it does stuff like SSL scripting, also things like that. We don't have it on all of our domains for a variety of really complicated reasons. The main reason being that we serve like HTTPS to almost everybody, like 99-point-something%. There is some subset of users which are just on such amazingly crappy devices that you just can't possibly serve it. We do have HSTS on as many domains as we can. But yeah, my stance is awesome. If you can do it, then do it. But like as with everything in security, it's not a binary, right? You got to do the trade-off.
Questions?
Do you think the ACNIC protocol is needed or used by SSL vendors? Do you think the ACNIC protocol
Oh, sure. I think if Let's Encrypt can validate itself as like a primary good quality CA, then I think everyone will be absolutely clamoring to take up their networks. Right? Do I see that happening like immediately? No. The SSL community and the SSL vendors in general have so many regulations that just to do something like this is a very time-consuming process. Once we have seen the success of Let's Encrypt, and we're already seeing that, I think it will be a much more interesting proposition.
Okay, so I have a question for you. Final one.
What's up?
What's up with SSL?
What's up with SSL?
Yeah.
You want me to say TLS?
Yeah, TLS.
People don't. Well, I don't know. Are you from Microsoft? Is that why you want me to say TLS instead of SSL? I don't know. Like, I feel like the whole SSL TLS thing is just non-conversation. I don't know. Like, I say SSL because my general rule is if something applies to SSL and TLS, then I will just say SSL. The reality is for this, I just want to simplify it. Like, this talk is not just being given here, it's also being given to other people who might not be as familiar with it. So I just want to say SSL, because everyone knows what that is, but TLS is like, I don't know.
Thank you, Chris.
Thanks.